Now let's look at how to solve this problem in Excel solver. I'm going to take a slightly different approach than what's given in the textbook. The textbook follows more of an algebraic type of approach, which sometimes can be confusing. So I'm going to take more of a modeling approach that you don't have to worry about the matrix and stuff like that. You just develop the model in a logical fashion and then use solver. So the first thing to do is to set up all the input values. So we have two computers and we have some requirements in terms of labor hours and then how many hours are available and how much profit per unit. Okay, so these are information given to us in the problem. So we have to first set up the input values of the model. All right, so these are the data that's given to us. So we need 5 hours of assembly time for X basic and 6 for XP, and 10,000 hours are available. So labor for testing 1 hour for basic, 2 hours for XP, 3,000 are available. And profit per unit are 80 and 129. Let's go ahead and format it properly. Okay. And it is a good idea to color code the data and the computations and the final result in a consistent fashion so it'll be easier to read and understand. So I'm going to require you to follow this pattern. All the input values must be assembled at the top. You should never use numbers in formulas down here unless, well, I wouldn't say unless, okay, never use it. Okay, always put the numbers, that is input data, right at the top, label them properly so everybody can understand what these represent. And I would color code. Okay, I'm going to use a light blue like that as input. Okay, so I know that in this modeling, wherever I see a light blue background, then that represents input values. Okay, and so that's the input. Now the decision variables. Okay, remember x sub 1 stands for basic and x sub 2 stands for number of units of XP that we're going to produce. So here we have to specify cells for those decision variables. So this cell will represent how many units of basic we will produce, and this cell will represent how many units of XP we're going to produce. So that's these two cells will now represent the decision variables. And once again, let's use a different color to represent decision variables. Okay, that's it. Those are the only two decision variables. Okay. Now we have constraints, right? So we have hours of labor constraint and maximum sales constraint. Okay, so maximum sales is for how many units of basic you can produce or you want to produce and how many XP you want to produce. And these maximum sales numbers are given in the problem. What, 1,000 and 1,200, right? Okay. Now once again, this is input. These are numbers given to us. So I'm going to color code that. So you should be consistent in your color coding. You can't just use color coding for some input and then not for others. So I think I'm not getting the right blue here. Okay. Now this so remember, this has to be less than or equal to, that is, the value that you enter in these two cells cannot exceed these two cells. Now let's align this properly. We don't want this less than sign on one side and the numbers on the other side. So let's align them properly. Now this is not used in the solver, as you will see. Okay, but this is strictly for the user understanding the model properly. Okay, so we know that by looking at this less than or equal to sign, that these values must be less than or equal to these values. But in Solver we have to specifically indicate that, and we will see that when we get into Solver. Right now we are using this more as a label to identify what kind of constraint we need when we do set it up in Solver. Okay. Next is the labor hours constraint. Okay, so now we have to figure out how many hours are needed to produce these many basic and XP, and the hours available. So here is 10,000 and 3,000. So I'm going to use a formula like that. So whatever is in E9 will be reflected here. And once again, this is the best practices convention. A particular number you enter once at the top, and then you refer back whenever you need that number. You refer back to that number with a cell address like this, E9. Okay, never type the number 10,000 a second time here, because if you need to change the number for some reason, then you have only one place to change it, and then once you change that, that will be reflected automatically everywhere else. Okay, so then copy that formula down. So now these are the hours that are available. Okay, and how many hours will be needed? Okay, so that is, here are the cells which will contain, once we solve the problem, you will have numbers. Right now it is blank, but when we saw after solving the problem, it will have some numbers like that. Okay. I don't know what the, we know the answer, but at this point we don't know. But if you feel comfortable with numbers and not blank cells, then go ahead and type in some numbers, but that's not needed. Okay, so when we use Solver, Solver will find the numbers for these cells. Okay. So what we need is, we need to multiply that many basic times 5 hours for each basic. So 5 times that cell, then plus 6 hours for each of these XP, so 6 times that cell. Okay, when you sum the two, 5 times that plus 6 times that, okay, so that will give you the hours used. So it will be like that times that plus that times that. That will give you how many hours you need. But this is not the right way to set it up. Okay, if you set it up like this, I will be deducting points from your homework, because when you have only 2 cells like this, it's not that difficult to set up the formula by multiplying corresponding cells. But just imagine if you have like 15 of this. So constructing a formula like this with 15 pairs is going to be really cumbersome. Okay, with 15, if it is cumbersome, just imagine if you have 100 or 200. If you have 100 or 200, it's just simply almost impossible. But fortunately in Excel, we have a function called sum product, which is what you must use. So sum product, you can give as many ranges as you want. The only requirement is that each range must be exactly the same size. For example, that, comma, that. Well, that. Okay. So these two are now exactly same size. So what sum product will do is it will take corresponding cells from each range and multiply. So it will multiply that with that. Then it will multiply that with that. So it will first find all these products, and then it will sum all those products. That's why it's called sum product, which is exactly what we did by going cell by cell, pairing them ourselves. So if you have a range that is 3000, you can just set up this formula very easily using sum product. Now the one thing that we need to do is, we want to be able to copy this formula down to the next cell down for testing labor, and for that the production must still come from C15 and D15. So you must change the cell address for the number to produce as absolute address. So that way you don't have to set up two different sum product formulas. You set it up once and then you copy. And again, that's something that I'll be looking for. You shouldn't type each sum product formula individually. Okay, so now we have 0 because we are not producing anything. So if you produce one of each, you see 6 plus 5, 11, 1 plus 2, 3. So if you produce one of that and two of that, you can automatically change. Okay. Now, once again, for the sake of readability, we will enter the type of constraint. And again, when you do this in your homework, you must indicate what type of constraint you are setting up between one side and the other side. Okay, you must include the labels like this. Okay, so now we have the two labor constraints, then we have the two sales constraints. All right, last thing that we are left to do is net profit. And net profit is again a sum product of profit per unit and number of units produced. Similar logic. Don't type in products of pairs of cells yourself. Use the sum product function. So profit per unit and then how many units you want to produce. And now that's the final result. So I'm going to color code it in a different color. Okay, so like that. So I'm using three different colors, one for input values, one for decision variables, and one for final output. So anything that is not that does not have background color, those cells have computations. Okay. So now we have set up the model. The next is to solve it using solver.